everyone. This is the first in a series of videos looking at the key skills involved in the linear relationships chapter of the higher maths course. Before we get into some of the meatier bits of the chapter, there are first 3 subskills that we have to make sure that we have developed. So those subskills are finding a midpoint of a line segment, finding the gradient of a perpendicular line, and finding the gradient of a line from an angle. So without further ado, let's begin. Okay, so welcome to your first higher maths note. You should be copying this down as you watch, and feel free to add anything to your notes that you feel may help you as we go along. So as you now know, the first topic of higher maths is called linear relationships. So let's take that as our heading. Now, this topic's got a lot in common with the straight line topic at National 5, which makes it a particularly nice place to start the course. There's an expectation that you know a lot of the skills already, and I'm going to assume that for the purposes of these videos. So from National 5, you will know this. A linear relationship is a relationship between 2 variables So a linear relationship is a relationship between 2 variables that produces a straight line when plotted on a graph. So before we go on and start to build on that information from National 5, let's first of all master those subskills. So when we have a line segment joining any 2 points, it's always possible to find the coordinates of the point which lies exactly halfway up that line segment. This point is called the midpoint. To find the coordinates of this point, we simply find the average of the 2 x's and the average of the 2 y's. So that means add the 2 x coordinates, divide by 2. In this case that will be -3 add 5, which is 2, divided by 2, which will give you 1. So the x coordinate of our midpoint is 1. For the y coordinates, it will be 5 add 9, that gives us 14, and half of 14 gives us 7. That tells us the coordinate of the midpoint will be 1, 7. So let's take a subheading of midpoints. So we'll just say this. To find the point which is exactly halfway between 2 others, so to find the point which is exactly halfway between 2 others, we simply find the average of the x coordinates and the average of the y coordinates. Now, there is a formula for this, but I think the best way for you to develop this skill and to actually work on it is just to see a few examples. So let's just put them in. So e.g., let's say your first example is point P, which is 1, 4, and point Q, which is 5, 2. Now we want to find the point which lies exactly halfway between P and Q. So the notation is capital M for midpoint, and then a subscript PQ, which tells us we're finding the midpoint between P and Q. Now conventionally we don't put equals, we don't write the point equals, we just go straight to an open bracket and we can write our answer in here. Now you will get used to doing this in your head, feel free to write some working at the side here if you want, but what we are going to do is we're going to take the average of the two x coordinates. So 1 add 5 would give me 6, so we add the two coordinates to get 6 and then we divide by 2, and 6 divided by 2 is 3. Similarly with the y coordinates, we take our two y coordinates and we're going to find the average. So 4 add 2 gives me 6, 6 divided by 2 gives me 3. So therefore the midpoint of P and Q is 3, 3. Okay, let's do a second example in there. Let's say we have points A and B. So A is going to be the point negative 3, 9, and B will be the point 11, negative 7. So that's slightly trickier because negatives are involved, but it's exactly the same process. Now think about what the notation is going to be. We're still going to use capital M for the midpoint, but this time it's the midpoint of A and B. So we're going halfway between A and B. Open our brackets straight away. First things first, average of the x coordinates. So negative 3 add 11. Negative 3 add 11 gives me 8. Divide by 2 gives me 4. 9 add negative 7. Well, that's the same as 9 take away 7, which gives me 2. Divide by 2, 1. So the midpoint of A and B is 4, 1. When we have two straight lines, it can be interesting to think about the relationship between their gradients. The obvious special case being two parallel lines which will both share the same gradient. But what if we take one of those lines and turn it through an angle of 90 degrees? Well, now we have perpendicular lines, so how has that affected the gradient? In order to answer this, we have to go back to thinking about what gradient actually is. So gradient is defined as vertical change divided by horizontal change. That is to say, every time a line goes along one box, how many boxes does it go up or down? So in the line you can see in the diagram here, we can add a triangle to say, well, when I go along one box, I go up 2. Vertical divided by horizontal, 2 divided by 1, gives us a gradient of 2 for that line. Well, let's take that line, turn it through an angle of 90 degrees, as we said, and the line we get is now at a right angle, it's perpendicular. How did that triangle then change? Well, everything's turned by an angle of 90 degrees, so we have the triangle shown. Let's think about vertical change over horizontal change for this triangle. Well, the vertical change is now actually going down by one box. The vertical change is negative 1, the horizontal change is 2, negative 1 over 2 gives us a gradient of negative 1/2. So a gradient of 2 becomes a gradient of negative 1/2 when we make it perpendicular. I'm going to show you some other examples and let's see if you can spot the pattern. Let's take a subheading of perpendicular gradients. Perpendicular gradients. Now again, from National 5 you'll be comfortable with the idea that two lines which are parallel share the same gradient. Perpendicular lines, as we've just discussed, are kind of like the opposite of parallel lines. So we can say this, for any two straight lines which are perpendicular, for any two straight lines which are perpendicular, so we know that means they meet each other at right angles. We know that the gradient of the first line, which we'll call M1, multiplied by the gradient of the second line, which we'll call M2, always must give us an answer of -1. Okay, that must always be true. So we can use that fact to say for any two straight lines that are perpendicular, the gradients must be the negative reciprocal of each other. So that means, e.g., if I have a line which has a gradient of 4/5, then I know that a line perpendicular to that line, and that upside down capital T is a symbol for perpendicularity. The perpendicular gradient must be negative, and then we can flip that upside down 5/4. So it's the negative reciprocal. Second example, if I have a gradient of -2/9, that would imply to me that a perpendicular line would have a gradient of, well, we have to multiply it by a negative and make it the reciprocal. If I multiply a negative by a negative, I'll get a positive, make it the reciprocal, flip it upside down, we get 9/2 will be our gradient of our perpendicular line. What if my initial gradient was 1/3? Well, if my initial gradient was 1/3, that would imply to me, let's follow the same rule, times it by a negative, so I know that my answer is definitely going to be negative, and I'll find the reciprocal. Flip it upside down, 3/1. Well, 3/1 is just 3. So perpendicular to 1/3 is a gradient of -3. What if my gradient's 1? Well, let's have a think about that. My perpendicular gradient, multiply it by a negative, so it's definitely going to be negative. This isn't a fraction, so it's hard to find the reciprocal unless we realise that 1 is just 1/1. And if it's 1/1 and I flip 1/1, I'm still going to get 1/1. So my answer is -1. So it should be easy to see that as a line's gradient increases, so does the angle that the line makes with the horizontal. So then we can see there is certainly a relationship between the gradient of the line and the angle that the line makes with the positive direction of the x-axis. So let's go back to that straight line that we looked at earlier. We calculated the gradient of that line was 2, and we did that by dividing the vertical change by the horizontal change. That was 2 divided by 1. But you can see that if you consider an angle in that triangle, and we relabel the triangle with opposite and adjacent, then tan of that angle, which we'll call theta, tan theta is going to be equal to opposite over adjacent. That's 2 divided by 1, which is 2. So hopefully you see that's exactly the same calculation that we did for gradient. So with a little thought, you will see that vertical divided by horizontal, which is gradient, is the same as opposite divided by adjacent, which is tan of the angle. So we can see then that gradient equals tan theta. So let's take a subheading of finding the gradient from an angle. Finding the gradient from an angle. So we'll say the gradient of a straight line can be found using the gradient of a straight line can be found using m equals tan theta. And we better just clarify underneath where theta is the angle between the line and the positive direction of the x-axis. So m equals tan theta, where theta is the angle between the line and the positive direction of the x-axis. So let's do an example 1. So example 1 will be find the gradient of each of the following lines. Find the gradient of each of the following lines, and then we're going to have an A and a B, and we're going to draw them. So for each one we're going to set up a Cartesian coordinate diagram. We're not going to fill it all in, we're just going to have a y-axis and an x-axis. And in this first example, I'm going to add a straight line which passes through the x-axis with an angle of 60 degrees. And that is all we know about the line. For part B, I'll draw a similar set of axes. But this time I'm going to have a line coming down the way through the x-axis, and I'm going to tell you that this angle in here is 45 degrees. Okay, so let's write solution underneath. And for part A, we will consider how to find the gradient. So we want to find the gradient of this line. Now, the only information I have is that the line makes an angle of 60 degrees with the positive direction of the x-axis. So I know I'm going to be using my formula. My formula is m equals tan theta. I want to find the gradient. I know that theta, which is the angle between the line and the positive direction of the x-axis, is 60. So m equals tan 60. And we can just put that into a calculator, and the answer should come out as the square root of 3, which is an exact value. You don't need to put it as a decimal. Root 3 is satisfactory for a gradient. For part B, we're going to be using the same formula, m equals tan theta. Now in this case, we don't actually have theta. Remember, theta is the angle that the line makes with the positive direction of the x-axis. The angle I actually want is this angle here. This will be my theta. So I am going to be doing tan of 180 subtract 45. I'm going to be doing tan of 135 this time. And if we put that into a calculator, the answer will come out as -1. So let's move on to example 2. So this time we're going to use the formula the other way around. This example is going to say find the angle that each of the following lines make with the positive direction of the x-axis. And you will get used to seeing this phrase, positive direction of the x-axis, and associating that with the formula m equals tan theta. So part A, we're just going to have a line which is y equals 3x minus 7. And part B, I'm going to give you a picture of this line. I don't have to, but I'm going to give you a picture so we can talk about it a little bit. Okay, let's say this line will look roughly like this. And the line is 3y add 2x, subtract 4 equals 0. Okay, so we're going to find the angle that that line makes with the positive direction of the x-axis, and then we want to find the angle that this line makes with the positive direction of the x-axis. So let's do our solution. Well, for part A, we were given the equation y equals 3x subtract 7. Now this question's made it quite easy for us. Remember, we're trying to find the angle that the line makes with the positive direction of the x-axis. So we know we are going to be using m equals tan theta. Now, we can see from inspection of this line that the gradient is clear. This is in the form y equals mx plus c. The gradient of the line is therefore 3. And this gradient of 3 can now be used in conjunction with this formula. The gradient is 3. So the question we're asking is, tan of what angle gives me an answer of 3? Well, I want to get theta by itself. I don't want this tan attached to it. I want to find the angle. So I take the tan to the opposite side and I do the opposite operation. The opposite of tan is inverse tan. So tan to the minus 1 of 3. And then I simply type that into my calculator, shift tan of 3. And theta works out to be 71.6 degrees. Okay, so nice and straightforward. It was just the inverse tan of 3. Now for part B, the equation we were given was 3y add 2x minus 4 equals 0. So the gradient hasn't just been gifted to us this time, there's a little bit more work to do. We're going to have to rearrange this straight line. So let's leave the 3y where it is. The opposite of adding 2x is subtracting 2x. The opposite of subtracting 4 is adding 4. And to get y all alone, which is what we want, we have to divide both of these terms by 3. So negative 2 divided by 3x, add 4 divided by 3. We can now see the gradient of this line is negative 2/3. Now a quick check, going back to the example. I am pleased to see that the gradient worked out as a negative. I can see this gradient is negative, so negative 2/3 is a pleasing confirmation for me. We'll go up to m equals tan theta and follow through to find the angle. So in this case, we've got negative 2/3 equals tan theta. We want to get that theta by itself. We'll take the tan to the opposite side and we will do the inverse tan of negative 2/3. The inverse tan of negative 2/3 gives me a negative answer. So the answer to tan to the minus 1 of negative 2/3 is negative 33.69. Well, at this point, that should ring an alarm bell for you. You can't have a negative angle. And we'll go back to thinking about that picture. We've got a negative angle. The calculator's actually told us the smallest angle it could between the line and the positive direction of the x-axis. We don't want this negative 33 angle. We want this angle here. So to calculate the size of this angle, we are going to do 180 subtract 33.69. So in this case, theta will be equal to 180 subtract 33.7 degrees. And 180 subtract 33.7 degrees gives us an answer of 146.3 degrees. So what do you take away from this? Well, when you have a negative gradient, you are always going to be subtracting from 180.